One of the benefits of being in the position of chair of a day like this is I get to ask plenary speakers to come and talk to you that I think are extraordinary. And in this case, Charlie beat me to it. And he asked him first, so we got him here anyway. Dr. Edwin May is an extremely extraordinary breed of cat. He is a physicist, classically trained. He is an empirical scientist. He claims to be a skeptic, but I'm not entirely sure I believe it. He is brilliant, capable, and if I was to give you all of his research work, I'd have to shoot you because most of it's still classified. Someday we'll probably get a chance to see the range of his true brilliance. Most of the work that he's done is just beginning to be declassified. So we don't get to see a whole lot of the kinds of things that he's done. Among the many awards that he has received are the Parapsychological Association Outstanding Achievement Award in 1996, the Outstanding Career Award in 2007, and the Worship of My Heart. I've followed his work for years and years and years and years, and he's amazing and marvelous. So I bring you a gift, a wise, a learned, and a capable spirit who understands what we're trying to do. Dr. Edwin May.
Well, Melinda, after an introduction like that, it's all downhill from there. Thank you for those kind remarks, and some of them are justified, but most are a bit exaggerated. It's a real pleasure to come and speak to you all here. I've not been a member of this organization, but I followed it carefully throughout the years, and I actually have 2 publications in the journal. With my late colleague Larissa Velenskaya, we reported on work that we first saw in the Soviet Union after the communists fell, and we had the pleasure of going there in the early 90s. So I have an interesting story, and let's get to it. Outline: current physics, forces, cross-section. Don't run out of the room screaming yet. These will all be easily understood momentarily. Mean free path. That's not an angry free path. That's spelled simply. Problems for non-material. These are serious questions for me. I'm going to talk about anomalous cognition. You know that term probably better as extrasensory perception, remote viewing, psi, a whole host of other terms. What is entropy? I'll describe that for you. Limits to the quality of anomalous cognition. Is there a limit? How good you can be to be a psychic? Towards a materialist model of precognition. That's a biggie, and a lot of my colleagues say in the world of parapsychology don't agree with this. Evidence-based materialism. I have to admit a degree of unabashed theft. I stole that term from the title of this particular conference. I just tweaked it a little bit. Evidence-based materialism. 2 approaches I want to outline today. One is, what does physics have to say about that? Weakly material interactions, I'm going to talk a little bit about, and a definition of non-material. I was talking to Melinda before we began this morning. I'm at the bottom of everybody's list as a competent philosopher. I can guarantee you that's the case. But so I thought, well, gee, I think I'll start reading the literature and ask some of my famous colleagues, do they have a definition of what they actually mean by non-material? Well, everybody sort of has an operational definition. They know what it feels like. They know what it looks like when it impinges upon them in this first-person experiential part. But no one has a quantitative definition of what we mean by non-material. And as many of you know, nature abhors a vacuum, so this crazy physicist rushes in, and I'll provide one for you. Parapsychology. My longtime friend and colleague and your president, Charlie Tart, believes strongly that the evidence in parapsychology is evidential for the against materialism, and I profoundly disagree. And I hope when I show you some of the evidence that we have in parapsychology, it will at least cause you to rethink the question. I'm not up here as an evangelical preacher of any kind. None of us know the answers here. This is just part of the interesting inquiry. Okay, you may not know this, but there are only 4 forces known in nature, just 4. And they're outlined here with more detail than you'd ever want to know. Gravity is the one we're most familiar with. It's keeping you firmly attached to your chair. But the other one that we experience routinely is called electromagnetic, the electromagnetic one. And that's this one. It's extremely strong and has a long distance associated with it. And it's that force that keeps you from sliding through your chair and going to the center of the earth. The electrons in your pants are repelling the electrons in the chair. And if that didn't happen, you would disappear and head for the center of the earth. Now, if you are an advanced yogi and can manifest the siddhis, one of those is walking through walls. So what they must, if they can do that, maybe it's because they've learned to de-energize electrons in some mysterious way. But right at the moment, those are the only 4 that we know. So working within that framework, physicists like to define interesting things, and one of the things they talk about here is something called cross-section. And cross-section is just a way of measuring how something interacts with something else, consciousness in the brain, for example. If I have a marble and I shoot other marbles at it, if I just miss, they don't interact. If I just graze a little bit, they interact, and if I hit them straight on, they bounce around each other. Well, the cross-section for that interaction is really easy to understand. It's just the area of the marble. If you miss that, it doesn't interact. If you hit it, it interacts. Well, quantum mechanics adds more complication of that, which we don't need to go into. The unit of measures that physicists use for cross-section is called barns. That is not an accident. They say you couldn't hit the broadside of one. That's where it actually arose. It's a little tiny unit. A barn is not as the kind that you can park your horse in. This is a little tiny one. It's 10 to the minus 24 square centimeters. 10 to the minus 24th, for all you mathematicians out there, mean a decimal point with 24 zeros before you get a 1. It's the technical term is MDS, mighty damn small. Some examples of what these cross-sections are like in lead. If you shoot energetic electrons into lead, they have about a 3,700 barn cross-section. That has no meaning for you or for me. If you shoot gamma rays, it's a different set. If you shoot neutrons, but here's an interesting one, neutrinos. Some of you may know what neutrinos are. They are things that result in when radioactive particles decay. They spit out neutrinos, and the sun sends out lots of neutrinos. And they are very, very, very difficult to detect. Their cross-section is 3 times 10 to the minus 17 barns. Little, tiny fraction. I mean, they are the most non-material particle we know about in physics. They just don't interact with stuff. I had a video here which doesn't work, so we get to save some time and move on. This was to show you graphically about what this is going to look like, so I'm inviting you to use your extrasensory perception skills and have a look at that video, even though it's not working. It's in this computer somewhere. Okay. Mean free path, the definition. That distance through a substance such the initial input of intensity of particles gets reduced by some factor. 1 over E, if you're technically. In other words, about 63% of the particles hit stuff. All right? Let N be the number of particles per cubic centimeter. You know, some lead has more than helium, for example. So for lead, it's some big number. Who cares? And there's an equation for how far something will go as a function of the mean free path. If you have a lot of stuff here, and the cross-section is very large, this number, you take a big 1 and divide it by a larger number, the mean free path is very small. That means if you have electrons hitting lead, you don't need much lead to stop them. So the question becomes, how much lead does it take to stop a neutrino? And I, of course, have an answer to that question. What I have here is this measure of interaction called the cross-section, and here are some things that I've already talked about. There's electrons, and that hits this curve here, and that tells you how many meters, and so on. Here are neutrinos, way up here. Now that's really interesting. It takes a bar of lead nearly 1 light year long before you got a good chance for a neutrino to smack into something. So that's pretty non-material. And even though many of my colleagues, I would accuse them of having lead for brains, the likelihood of a neutrino interacting in your brain is also MDS, mighty damn small. Well, let's go more non-material here. A cross-section for non-material consciousness? Well, all right, it's non-zero maybe. Well, here I've just made up a number. And you'll see why I made up a number for that cross-section, because it would take a chunk of lead from the Earth all the way out to the edge of the universe before that consciousness, mostly non-material particle would interact with it. This is a serious problem. If the object cannot interact by the 4 known forces, it cannot be experienced or detected. Other forces have been looked for, but not yet found. I mean, there have been great searches for 5th forces and 6th forces. Most of the models in physics these days do not require yet a new force to explain some data, other than consciousness itself, perhaps. But nonetheless, what we know so far, there isn't. So I have a definition of non-material. A non-zero cross-section is required for an interaction. If a new force is found to supply that cross-section for consciousness, then a consciousness interaction with the brain becomes, by definition, material. Here's my definition, non-material. The cross-section for all interactions is identically 0. If that's true, and it's a big capital if with an IF, if that's true, then as you see logically, at least from a physics point of view, consciousness cannot be non-material. It has to interact with the brain somehow. Okay, as I said earlier, I rank at the bottom of everybody's list of competent philosophy. But given that that has never stopped physicists from talking about stuff of which they know absolutely nothing, I'm about to prove that point to you. People say that pictures are worth 1,000 words. My 3 pictures here are worth 3 words. I've done a little editing. When I showed this to my wife, who's in the back there, it didn't have a censor to this guy's bare butt. She said, hey, if you're going to a conference in Colorado, please put, so I did. All right. The 3 words are bare, assertion, fallacy. Or, in English, putting the hypothesis into the premise. As you can tell from my shirt, I spent a lot of time in India. And I listened for 40 years now, endless discourses by some very clever people about the nature of philosophy and survival of bodily death and reincarnation and all those wondrous things we love dearly. And every single one of them put their answer into the premise. They start from the position that the soul exists and is non-material and will survive bodily death and go from there. That, to me, is one of the classic, and I didn't invent this term, actually, bare assertion fallacy. It's very, very prevalent in a lot of Western and Eastern philosophies. And I tend to be kind of grumpy about that. I call people's attention to it. If we want to know how this is going on, it's not fair to put the answer into your premise without being able to test it. Okay. To illustrate my point, I had the honor of being invited to a seminar at the Ramakrishna Mission Institute of Culture in Kolkata, India. That's what it looks like from the balcony where my room is. And they attended to my material needs by providing round-trip airfare, giving me access to, that's my bedroom, really lovely on the campus. And this is what the seminar room looked like. This guy and this guy are Ramakrishna order monks. You can't see very well here. This guy is a Buddhist monk from Nepal. This guy is a neuroscientist and a physicist. It was an amazing meeting for 3 days to sit and talk about the nature of consciousness. And this guy, Swami Sarava, I cannot pronounce his name. You can read it. He came from marketing, this guy. And so he knew about PowerPoint. He had a good sense of humor. And he came to my defense because there were a lot of very dismissive materialists in the room. dismissive non-materialist, dismissing materialists. He came to my defense, and in his presentation, he kept referring to something that I talked a lot about, promissory materialism. That is, you're right, we cannot explain a lot of the richness of qualia that goes on inside of our souls and goes inside of our experience. We cannot yet explain that. Neuroscience is nibbling around the edges rather healthily at that. And I promise you, by Thursday, next Thursday at 3 in the afternoon, we will know the answer, or maybe 100 years from next Thursday. And, well, it's a good bet, because if you look back through the history of science, when we as a species have done promissory whatevers, it tends usually to be true. So if you're betting, it's not a bad bet. And he agrees with me, and he and I are now email dialogue, and I could easily work for this guy, even though we have differing viewpoints of the interpretation of the data. So, from the physics part, given what we know, consciousness must be material. And there's a big caveat there, given what we know. It may be that there are some, in fact, for sure, when scientists try to invent science by fiat, I know this is true and that's the answer. One of the most famous people that did that was Lord Kelvin, and I think 1902 said, well, we're done with physics, we've got all the answers, and 3 years later Einstein changed the nature of everything. So it's really dangerous to say we're done, and so understand this comment in that light, please. Okay, I'm going to switch gears. I'm going to switch now to ESP research and some of the work that we've been doing to try to convince you there is some evidence for a materialist explanation for something as bizarre as precognition. In other words, peeking slightly into the future. I've redefined the terms here, anomalous cognition instead of these more familiar terms, only because it is easier to understand. It describes the observable without putting a mechanistic overlay, extra sensory perception. Well, it says it's sensory, and extra means it's something we don't, it's something beyond the 5 that we have, and perception maybe. So what do we see? People become aware of stuff in ways that we don't currently understand. What better phrase to use than anomalous cognition? And I'm pleased to report it's catching on. Okay, so here's how a rough laboratory schematic would work. We have a participant and a monitor locked away in a room at 10 o'clock in the morning. We have a computer randomly generates one in our set of 300 photographs, okay? At that point, neither participant nor the monitor have any idea which one was selected. Here's one that might look familiar. It's my home in Palo Alto, actually. Oh, wrong picture. Okay, at this point, the picture's been chosen, but neither the participant nor the monitor have any idea which one was actually chosen. So the monitor is free to engage in a structured interview as to what is going on with regard to this photograph in her head. So that goes on for about 15 minutes, and some fraction of the time, a miracle happens. She gets sometimes a very clear mental image picture of what that photograph looks like. This does not qualify as an analysis. We give feedback and we're done. So how do you analyze whether something actually happened? Well, here's some real data from I'll use the polite term, a tough-ass Apple engineer who didn't believe in any of this sort of stuff. And this is everything he did with this kind of protocol, and I'll translate it. He says, intersection, notch your groove, and drew that. Wave, seawall, looking down, gap. And I would challenge you out there to look at this and say, oh, well, that's a photograph of... ESP is a lousy way to gather information. It is the bit rate, the amount of information gathered by extrasensory perception, at least in the laboratory, does not allow one to look at this really fairly high quality, good remote viewing and tell you what the picture is. So how do we assess what went on? The answer is something called rank order analysis. There's the picture you just saw. And one of these 5 pictures is the right answer. But the judge, me in this case, was not aware as to what the intended target was. This isn't as easy as it looks. The judge's job is to find which picture best matches that drawing, second best, third best, and so on. So there's waves. Well, there's waves there. Well, there's an X, but there's X's over here too, you know. Those look like nice X's. There's a seawall. Well, it's not a seawall, but it's a wall of rock with water coming down. How allegorical do you want to get? And there's some gaps looking down on the city. So each of you have your own choice. What I chose, that was my first guess as to what was the intended target. In my view, it best matched those. The beach scene was second, the wall of water third, and so on. Turned out I got that one right. Now, don't get scared. This is a lot of statistics. The bottom line was we used 3 Apple engineers, and one of them was individually significant, and the whole study was really wildly significant. So you don't have to believe in this stuff to actually have the experience of it. I won't go through that. This is Professor Utz. She is a statistician now at the University of California at Irvine, and this is what she had to say in the CIA report analysis of our work and the field's work. The bottom line, it meets every single sets of criteria that are required for the existence of a genuine phenomenon. Okay, we switch gears a little bit into entropy. And I'm going to go through this a little rapidly. Entropy is a measure of disorder. That little guy in the upper right-hand corner is my desk. The second law of thermodynamics says that the entropy of an isolated system will never decrease. That turns out to be the most supreme law of physics, in my estimation. That second law of thermodynamics holds for the chemical level, the atomic level, and if Stephen Hawking is correct, even at the black hole level, cosmologically. So it is unlikely that subtle energies or extrasensory perception are going to violate this law. It doesn't mean they can't, but it's not a good place to start. Leo Szilard, a famous Hungarian fellow, first connected thermodynamic entropy with information. Okay. Turns out entropy gives us our feeling about time moving in one direction. Here are 4 pictures. None of you, I hope, would have a problem of ordering these pictures temporally in terms of age. Easy to do, right? Time moves in one direction, right? Wrong. Here's an experiment. The bottom part there is bromine brown gas, and at the top is air, and at the moment there's a glass plate separating them. And if you pull out the glass plate, you get a movie that I'm about to show you on the left. Watch what happens carefully. The brown gas sort of uniformly migrates across the entire, both canisters. And if I were to run that movie backwards on the right, it goes the other direction. None of us would have a problem of telling which direction did I run the movie, which one is going forward and which one's going backward. The one on the right violates the second law of thermodynamics. It also goes against our experiences. But there is a problem. Let's examine this more carefully. Here's a little animation of what's going on inside that. The little brown balls represent the bromine, the other one represent the gas molecules in the air, and one of them is running forward, and one of them is running backward, and to be honest, I don't remember which is which, and nor can you. The fundamental laws of physics are down there saying that time is bidirectional. So what relates these molecules zipping around, banging into each other, and the whole thing comes forward to us, telling us what direction the movie is running into. That is well understood. I'll say it in jargon. It is the density of final states argument. It's the second law of thermodynamics. It has to do with things like, that's it. I'll just leave it at that. But it's an emergent property of large numbers. So at the micro level, time is reversible. The second law of thermodynamics gives us our sense of time, and so on. Okay. What does entropy have to do with ESP? Well, a lot. And I'm not going to bore you with the arithmetic that went into producing this. I can compute the entropic value of these 2 photographs. And it sort of looks like a topological survey map here and here. And this one is more hilly and bumpy than this one is. Turns out this one's much easier to see by remote viewing, much. I'll leave that out because I'm running out of time. The answer is, the more information you shove in one end of this pipe, the more information you get from anomalous cognition out the other end. Boy, does that sound profound. Are you kidding? That sounds trivial, but it's an important thing to be able to show quantitatively in the laboratory, and we've done that. 7 formable experiments have produced these results, showing that ESP, anomalous cognition, is related to changes of entropy of the target system. That's the take-home message here, and it's extraordinary. Is it a clue to precognition? Anomalous cognition is related to change of entropy. Change of entropy gives us our sense of time and direction. That is a huge clue. I've plotted a relationship that has nothing to do with ESP or subtle energies. It's this thing. This is entropy along this axis, and this is binary hitting rate. If you flipped a coin 100 times, what fraction of it landed? 1. That curve has no relationship to ESP. But I can, just for the fun of it, plot some ESP studies on it. These are the best ones I could find out here, and here's some that didn't work. Clearly, it's not exhaustive, but I started to think, wait a minute, how come the best ones I know about seem to be bounded by this curve that have absolutely no relationship whatsoever? So let me look a little further. You're all familiar with the famous Zener cards. Here they are. And it's possible to compute their changes of entropy. Here they are, the average. So I can look at Zener cards in that last picture. There they are. The best study that we could find in all of the Zener card literature going back 60 years is right there. The little tiny error bar tells you the uncertainty in what the answer really lays. And it lands right on our limit curve, proposed limit curve. Here a bunch down here at chance. So I started to look at this in a little more detail. Speculation. Maybe this is an okay region by psi, and anything in the white region here is not allowed for some unknown reason, but it does begin to look like a limit of some form. Let's look at this in more detail. One of my colleagues sent me 10,829 sets of 25 ESP card, the results of that, from the 30s and 40s. And I've plotted them here. Some of them are at chance, and some of them are below chance, and here's a few above chance. This line here represents that blue line where the limit was, okay? And this represents what are called the 95% confidence line, and a few of them sneak out here past that. But a very small percent of them sneak out there. There's huge evidence of psi in this data. The mean of the archive set is 0.523, where 0.500 should be it. That doesn't sound like much, but it's huge statistically. So what does a non-ESP event look like? I was able to simulate that in the computer, and that's the blue graph, and I get exactly what we'd expect, 0.5 here. And very few of them come across this limit here. What it looks like, for reasons I can speculate if you wish, that something has to do with entropic changes in our brain might be serving as a possible limit for extrasensory perception. That's what this suggests, if this is true. This is an interesting idea. I was in Moscow last October. This guy's head of the Russian Academy of Sciences. His name is Gulyayev, Yuri Gulyayev, and this is his first deputy. They've invited me to come there to spend 4 months working with solid-state physics people to round out this idea technically to see how it should go. And we're trying to figure out a way to make that happen linguistically and financially, but they are vitally interested in, and that's no mean slouch. This guy has been nominated 12 times for a Nobel Prize in Physics. And he speaks totally fluent English, and he laughed and he said, always a bridesmaid, never a bride. So here we go. You think this is the real answer of how all this works. This is two physics people talking, and then in the middle, a miracle happens to explain how all this works. Conclusions and implication. Psi, or anomalous cognition, meets all standards set by science for being real. Evidence for being mediated by a sensory system is pretty profound, actually. Precognition, my view, is likely the only type of psi. Nobody in my field except a handful agrees with that, and I'm sure Charlie doesn't agree with that. Limited by the second law of thermodynamics, that's what the data say so far. Implications and challenges. Physics, how does information go from across space and time? Physiology, how does the brain detect psi? Philosophy, consciousness is likely material manifestation and may be an emergent property of the brain, maybe. End of materialism, way premature. Thank you. I finished a little rapidly. I don't know, do we accept questions here and all that? I can't hear you, I'm sorry. Okay, very good. And 0 means what? I see. Oh, come on, you got to have questions, please. I'll ask questions. I'll warn you in advance.
Good morning, Helen Masloka. Very, very interesting presentation.
Thank you.
And I'm wondering how you might put into context Dean Radin's work, and particularly his study on voodoo, where instead of doing harm, he used massage.
Yeah, Dean and I are close friends. He worked for me at SRI for a year, and then I worked for him for a year, and now we don't work with each other in boss-underling way. We're colleagues. We have some profound disagreements about things, but we also have some profound agreements with things. The problem is, and thank you for your question, most of the data in our field to analyze whether something has gone on is fundamentally statistical in nature. And it isn't the case that in the control condition it never happens, and in the effort condition it always happens. That's very rare. That almost never happens in medicine, for example, or in quantitative healing research, it never happens. So once you start using statistical inference, this brings in something really ugly. And I invented a model called decision augmentation theory, based on a lot of very competent work by others, Rex Stanford being one, which suggests experimenters who have a cherished outcome can use their psychic ability to make it look like their cherished outcome is true, even though it is not. And that's troublesome for all of us. And when you look at, for example, the random number generator database, which is huge, including the Global Consciousness Project, which some of you might be aware of, where random generators are scattered all over the world, and they are the cherished hypothesis is that these hardware devices respond to human events in measurable ways. Or there's another explanation that the experimenters are making it look like that. This isn't an accusation of fraud, it's an accusation of them being psychic, which is different. I don't know if that answered your question or not. Thank you.
Hi, Ed.
Hi.
I'm curious if you would consider doing a meta-analysis of a larger body of psi research to prove your point that it doesn't violate anything regarding entropy. Because you showed Zener and then your own data, but that's really a limited database set compared to a larger body. It seemed to me a meta-analysis would be more convincing, although it would be a lot of work.
That's a really good suggestion. I would be happy to do the meta-analysis. The problem is, for example, there are only like 7 or 8 studies in the anomalous cognition on my graph. You know, that doesn't make a theory. The problem is I need data like the entropic changes of the target to test this, and no one does that, or very few people do it. Fortunately, I was able to get a rather huge data set of 60 years worth of experiments in the card guessing. But you're right, I wish there were others, and some of my colleagues in the UK are replicating independently these studies and getting the same results.
I'm curious to challenge your concept that precognition is the only true psi skill.
Good. Glad somebody did.
I've done a series of studies utilizing biophoton imaging.
Yep.
We used a camera which we supercooled down to minus 80 degrees C. We used practitioners that worked on leaves, so it was placebo-controlled material. We matched the leaves for size and weight. We pre-examined the leaves for the amount of photon emission so that they were matched by 0.003 in terms of photon emission over a 3-minute period. We took the leaves and the practitioners worked on the active leaf for a period of 10 minutes, and then we placed the 2 leaves side by side in the imaging chamber, and we did an hour and a half of imaging of each paired system. And we did, in fact, have significance. It was 0.005 in terms of the data in a chi-square analysis for the biophoton output of both a healing condition and a killing condition. So we demonstrated both depending on the intention of the practitioner. The point of the killing condition was to see whether or not the practitioners might be able to kill cancer tissue.
Okay,
but they killed live tissue. So precognition, to me, doesn't necessarily fit that
Okay,
model.
I'll give you a better example to shoot my own theory down because I'm going to shoot yours down right now, Melinda.
Rock on.
You use statistical inference, and you proudly quoted the p-values and chi-square analysis and all that. What that does is leave open the door for experimenter psi rather than the PK condition we'd all like it to be. But let me give you a counterexample that challenges me. Dean Radin and Russell Targ and a very small handful of others, I think, have done spoon bending. Now, I'm not talking about bending spoons this way. I'm talking about here's the bowl of the spoon you sip out of. They bend the spoon across the bowl itself. Now, I'm going to commit one of those long-standing philosophical fallacies. I can't think of a way to do that. If you gave me a spoon and $1 million and said, come on back in a month with a bent spoon that's not broken, I wouldn't have a clue where to begin. To me, that challenges my concept of precognition.
I have 50 at my house.
Okay.
I taught a PK class in January, so.
Okay. As I preface my remark, hardly anybody agrees with me with this. I can give you a handful of about 6 names, but that's a tiny fraction, and Charlie's about to kill me over here, I can tell.
Hi. Let me see if you agree with this, that we have a line between what is known or reasonably known and a line beyond which it is not known.
Sure.
And beyond which most people dismiss things, but the scientifically minded said, just wait, we'll get there. We just don't have it yet. And this is marched through history. Mm-hmm. And so I don't see any argument about materialism and non-materialism. It's, if everything behind the line is materialism, okay, but that line keeps shifting, and it always has in the history of science.
Yeah, I completely agree with that. In fact, with this Swamiji that I'm very friendly with in India, that's one of the reasons we can work so well together, because we both hold that philosophy that this is not a war between one side and the other, and often it's framed that way from both sides, which I get profoundly distressed at. This is too important to make it a we versus them. We need to figure out how it works. I'm convinced that we're on the right track. And my interpretation of the data is leading me in that direction, but there are other valid interpretations of the same data. Thank you for your question.
Just one last addendum. To my friends who say, why are you interested in the supernatural? See, I say, because I don't even think that word means anything.
Me either.
It's everything is natural. It's just a lot of it isn't explained yet.
That's right. Thank you. Okay, Charlie.
I want to reinforce a point of yours, Ed, because it's particularly relevant for subtle energies research. Can you hear me all right?
Yeah, I can.
Yeah. This experimenter effect. You and I used to be both on a discussion group of mainly experimental parapsychologists. You left a few years ago because I think you thought we were wasting a lot of time. But I've since brought up this question of some experimenters seem to be doing it psychically themselves rather than finding out their subjects. And I've constantly said, and so of course we should study the experimenters to see what's the characteristics of experimenters who have it. Recently I asked a simple question. How many of you would volunteer to say, take a few psychological tests, right? 2 people out of 50 people volunteered.
That's pathetic.
There's enormous resistance among experimenters to admitting that the experimenter is part of it.
Yeah.
And I can understand part of it psychologically, you know, because the thing you can do is, well, I'm a scientist, I'm perfectly objective, I do things logically, nothing else matters. It's really important in subtle energies research because there's a temptation to get caught up in these interesting gadgets that supposedly make subtle energy work. Well, maybe, but maybe it's the experimenter making them work.
Yeah. Couldn't agree with you more, Charlie. That's the white lab syndrome, that people think they're doing science when they are really ignoring a big chunk of it. And that's true in medicine. It's true in double-blind random control medical trials especially. I have a colleague who used to be the Army commander of the Medical Research and Development Command, and I challenged him. I said, you send samples out to various universities looking for toxicity. How about if we have a batch that's completely neutral, and we'll send one batch out to universities and bias them for its toxicity, the same batch to other schools and say it biases towards the benign effects, and he wouldn't do it because he was afraid of the result. Interesting. I'm out of time. Thank you for your questions and in inviting me to talk to you.